Assalamu alaikum, good morning, namaste, sat sri akal, buenos dias. My name is Raja Salim Akhtar. Welcome in this new video. Now we solve some important examples and exercise. Number 1. If tangent and binormal at a point of a curve make angle theta phi respectively, with a fixed direction, show that sin theta over sin phi, d theta over d phi equal to minus kappa over torsion tau. Solution. Let T unit vector and B unit vector B unit tangent and unit binormal at point P on a curve C. We draw a rough figure. This is a curve. This is a point P. Here along this direction is a B unit vector binormal, and this is a tangent. Here is T unit vector. We draw a fixed direction. Fixed direction. A is a unit vector. This makes angle theta. Angle phi. Yes, sure. Let A be a unit vector along a fixed direction The angles theta phi are shown in figure. No. A unit vector dot t unit vector is equal to A magnitude t unit vector magnitude cos theta, and A unit vector dot B unit vector is equal to A vector magnitude B vector magnitude cos minus phi. This is equal to A unit vector dot t unit vector equal to cos theta, unit vector magnitude 1 1, and A unit vector dot B magnitude is equal to A dot B is equal to cos phi. Because A unit magnitude 1, B unit vector magnitude 1, T unit vector magnitude is equal to 1. Differentiating with respect to arc length S, we get d A unit vector over dt dot t unit vector plus A dot dt unit vector over ds equal to cos derivative minus sin theta d theta over ds, and d A unit vector over ds dot b unit vector plus A unit vector dot db over ds equal to minus sin phi into d phi over ds. A unit vector along the fixed direction, dA over ds is equal to 0. First term will become 0. 0 plus A dot dt over ds minus sin theta into d theta over ds. Similarly here, first term is 0. A dot db over ds equal to minus sin phi d phi over ds. This implies A dot, using the formulas, Serret-Frenet formulas, dt over ds kappa n equal to minus sin theta d theta over ds dB over ds. Second formula, minus torsion n unit vector equal to minus sin phi d phi over ds. using formulas. This is equal to kappa A unit vector dot n vector minus sine theta d theta over ds minus tau n unit vector A unit vector dot n vector equal to minus sine phi d phi over ds. Now dividing both equations 1 and 2. Dividing equation 1 by equation 2, we get kappa A dot n unit vector over minus tau A dot n unit vector equal to minus sine theta d theta over ds over minus sine phi d phi over ds. This is equal to minus kappa over tau equal to sine theta over sine phi into d theta over d phi, or sine theta over sine phi d theta over d phi equal to minus kappa over tau torsion as required. Prove that the position vector of the current point on a curve satisfies the differential equation. D by ds sigma d by ds rho d2r over dt ds square plus d by ds sigma over rho dr over ds plus rho over sigma d2r over ds square equal to 0. Solution: left hand side d by ds sigma d by ds into rho d2r over ds square plus d by ds into sigma over rho dr over ds plus rho over sigma d2r over ds square. This is equal to d by ds. We know that sigma is equal to 1 over tau d by ds, and we know that rho is equal to 1 over kappa d2r over ds square equal to dt over ds plus d by ds. We know that sigma is equal to 1 over tau and rho is equal to 1 over kappa. So sigma over rho is equal to kappa over tau dr over ds is equal to t unit vector dash. Only t unit vector, not a dash. Plus similarly rho over sigma. Rho is equal to 1 over kappa, sigma is equal to 1 over tau. So rho over sigma will be tau over kappa, tau. d2r over ds square. This is equal to t dash, t unit vector derivative. This is equal to d by ds 1 over tau d by ds 1 over kappa. Dt over ds is also can be written as t derivative plus kappa over tau constant, and this is equal to dt unit vector over ds plus tau over kappa t dash unit vector. This is equal to d by ds into 1 over tau d by ds 1 over kappa using the Serret-Frenet formula. T dash is equal to kappa n plus kappa over tau. This is kappa n plus tau over kappa. Here also using Serret-Frenet formula, kappa n unit vector. This is equal to d by ds 1 over tau dn unit vector over ds plus kappa square over tau n unit vector plus tau n unit vector this is equal to d by ds 1 over tau again using Serret-Frenet formula number 3, dn over ds, this is equal to tau b unit vector minus kappa t unit vector plus kappa square over tau n unit vector plus tau n unit vector. This is equal to d by ds into b unit vector minus kappa over tau t unit vector plus kappa square over tau n unit vector plus tau n unit vector. This is equal to db unit vector over ds minus kappa over tau dt unit vector over ds plus kappa square over tau n unit vector plus tau n unit vector. Dt over ds kappa n again using here, and db over ds is equal to Serret-Frenet second formula minus tau n minus kappa over tau dt over ds kappa n plus kappa square over tau n plus tau n unit vector. So this cancel with this, and this term k square over tau n will cancel this. This is equal to 0 and right hand side. Prove that t unit vector dash t double dash and t triple dash triple derivative equal to r vector second derivative, r vector third derivative, r vector fourth derivative. This is equal to kappa 3 kappa tau derivative minus kappa derivative tau equal to kappa 5 d by ds tau over kappa. Solution. We know that dr over ds equal to t unit vector, or r dash is equal to t unit vector differentiating with respect to arc length S, we have R double dash is equal to T dash, R third derivative is equal to T second derivative, again fourth derivative, 3. Therefore, we have T dash, T unit vector double dash, T unit vector triple dash in scalar triple form equal to R double dash, R triple dash, R fourth derivative, 1 2 3 4. Now we know that T dash is equal to kappa n differentiating with respect to arc length S T unit vector double dash is equal to kappa dash n unit vector plus kappa n unit derivative. This is equal to kappa dash n unit vector plus kappa using Frenet third formula tau b unit vector minus kappa t unit vector. This can be written as kappa dash n unit vector plus kappa tau b unit vector minus kappa square t unit vector. Differentiating again, with respect to arc length S. T unit vector third derivative equal to u into v form kappa double derivative n unit vector plus kappa derivative n unit vector derivative plus 3 terms. First kappa derivative tau b unit vector plus kappa tau derivative b unit vector plus kappa tau b unit vector derivative minus two kappa derivative t unit vector plus kappa square t unit vector derivative. This is equal to kappa double derivative n unit vector kappa using here Frenet third formula, tau b unit vector minus kappa t unit vector plus kappa dash tau b unit vector plus kappa tau dash b unit vector plus kappa tau, using here Serret-Frenet second formula, b unit vector dash derivative minus tau n unit vector minus 2 kappa derivative t unit vector minus kappa square. Here again using Serret-Frenet first formula, t unit vector dash is equal to minus kappa n unit vector. This is equal to kappa double derivative n unit vector plus kappa derivative tau b unit vector minus kappa derivative tau unit vector plus kappa derivative tau b unit vector plus kappa tau derivative b unit vector minus kappa tau square n unit vector minus 2 kappa derivative tau unit vector plus kappa cube n unit vector summing all these terms and taking common kappa double derivative minus kappa tau square plus kappa to power 3 into n unit vector minus 3 kappa derivative t unit vector plus 2 kappa derivative tau plus kappa tau derivative into b unit vector. Also we have in scalar triple form t unit vector derivative, t unit vector second derivative, t unit vector third derivative equal to, you can use here commas or without commas, scalar triple notation. Scalar triple product. This is equal to 0 kappa 0 minus kappa square kappa derivative kappa t kappa tau minus 3 kappa kappa dash kappa double dash minus kappa tau square plus kappa raised power 3, and the next term 2 kappa dash tau plus kappa tau dash. Expanding this matrix, minus kappa minus kappa square into 2 kappa dash tau plus kappa tau dash. Minus kappa tau into minus 3 kappa kappa derivative. This will be equal to kappa square kappa dash kappa dash tau minus kappa power 3 tau dash derivative. Multiplying by kappa minus kappa cube kappa derivative tau plus kappa raised power 4 into tau dash. It can be written as kappa, taking common positive term first, kappa tau derivative minus kappa derivative into tau no we can also write it t unit vector dash derivative double derivative into 3 third derivative equal to kappa 3 into kappa square kappa t derivative minus kappa dash tau over kappa square. This term is equal to kappa raised power 5. This will be d by ds tau over kappa. Hence we have t unit vector derivative, t unit vector double derivative, t unit vector triple derivative equal to r second derivative, r third derivative, or fourth derivative equal to kappa 3 kappa tau dash minus kappa dash derivative tau, yeah, this is equal to kappa 5 raised power 5 d by ds tau over kappa. Here you can use commas or you can write without commas, depend upon you which notation do you want to follow.